Lesson 10.5, Polar Functions, what you'll learn about polar coordinates, polar curves. Let's see the difference between rectangular coordinates and polar coordinates. Rectangular coordinates, their purpose is to find a location on the plane. And so we're used to going over 2 units and up 2 units. Let's take a look at another way to find the same position, but using a radius and using an angle in reference to what we call the pole. And you might want to think about it as the positive part of the x-axis. Using this information, we're going to be able to find the same location. It tells us what the angle is that we have to turn from the pole, and it tells us the distance from the origin that we have to go. And when we do that, this location right here is the same as this location. Let's take a look at this once again. We're going to take a look at this location. It's going to be represented by the radius, which is negative 2 root 2, and the angle, which is negative 3 pi fourths. So we're going to, from the pole, we are going to go negative 3 pi fourths, and normally we would be going a radius of 2.2 root 2, but unfortunately it says a negative, which means you have to reflect across the origin, and when we do that, we reflect and we get this location. Now we can do it another way. We can actually, our radius can be positive 2 root 2, and our angle can be pi fourths. And again, we're going to go over pi fourths. We're going to rotate from the pole, and we're going to go a distance, a radius of 2 root 2, and again, we're landing in the same spot. This is done with the xy axis, but we can also do it with a polar graph, and we would do it much the same way. We would make an angle of negative 3 pi fourths, so we're going to go around this way. Normally we would have a positive radius, but since it's a negative radius, we have to go in the opposite direction. Now 2 root 2 is approximately 2 times 1.4, and 1.4 is about 2.8. So from here, we would go out 1, 2, 2.8, and here's our location right here. Now over here, we would be going out pi fourths, so we would be turning this way, and we would go out a radius of about 2.8, 1, 2, 2.8, right about here. And again, we have the same location. All right, let's practice converting. And this time we're going to convert from polar to rectangular. So let's go ahead. Here's our pole. We're going to turn pi halves, and we're going to go a distance of 4 units. Now that means that this point in coordinate form in rectangular coordinates will be 0, 4. Let me go ahead and do this one now. And this one is going to go down pi fourths, and our radius is going to go in the opposite direction, which is right here. This is going to be root 2. Now this is, remember the reference angle is pi fourths. So our the sides of the right triangle will be negative 1 and 1 because we're in quadrant 2, and so this answer would be negative 1, 1. Now let's practice changing rectangular to polar. So let's go ahead and graph. And 1, 0, this is our radius and this is our angle. So we can write that as 1, 0 radians, or 1, 2 pi radians. We could even say negative 1 pi radians, and we would get the same location. Let's go ahead and do this one. So we're going to go over 1 and up 1.7. So we're going to go over and then up. And what we would like to do is find the radius, which is going to be 2. And so our radius will be 2. And the angle that we're making right here is pi thirds. And again, that's not unique. All right, so this is telling us that we do not have a unique way to write our polar coordinates. They can be unique if you restrict the radius and you restrict your angle. Okay, let's go ahead and graph some curves. This says r is equal to 2, and it doesn't give us any specification on theta, so all the radius has to be is 2. Here's a radius of 1, here's a radius of 2, so these are all the points that have a radius of 2, and there's a lot of angles that go with that. What about negative 2? Negative 2, and again, theta is not being given, so you could go out an angle, and then you go reflect it, go out an angle over 2, reflect it, and you could keep doing this and you're going to get the same curve. Over here, the radius isn't being designated here. All we know is radius can be anything, it's only the angle that is pi 6. So it'll be that line. And the reason I'm graphing down here is the radius could be negative. And so if we could go pi 6 and then have a radius that's negative. Okay, let's go ahead and use our calculator to graph some things. And the first one we're going to graph. Before we start, I need to show you mode. It has to be in polar. And my window is going to go to 2 pi. And here's my y equals. It's entirely different than the other forms that we've had. I'm going to write sine of 6, and if you press the variable key, it'll press theta. And then go ahead and hit graph. Now this is what we call a rose curve, and this particular rose curve has 12 petals, we call it. Let's go to y equal, and we're going to clear it, and we're going to write this next one. 1, take away 2, cosine, variable key, parentheses, and then we'll press graph. Now this is called a limacon. And we're going to do one more, y equal, and we're going to clear 4 sine of theta, and we're going to go ahead and graph. And it doesn't look like we have the whole graph, so I'm going to go down here and see a little bit more y. Go ahead, 5. Now, this is actually a circle, and how do I know that? Because this distance is 4 and this distance is 4 here. So if I went ahead and squared it up, it would look more like a circle. Alright, so relating polar and Cartesian coordinates. Let's take a look at this picture. We can see that the radius, x, y, and r, there's a relationship. It's the Pythagorean relationship. We can see we can write x and y in terms of the radius and angle. In geometry, we would say the cosine of theta is equal to the adjacent over the hypotenuse, and we're just writing it this way instead. We would say the sine of theta is equal to the opposite over the hypotenuse, and we're just writing it this way. So it gives us a formula to convert. And again, tan of theta is opposite over adjacent, and here's our other conversion formula. So these have to be memorized. Now let's take a look at how we would convert something like this into rectangular. And the idea for this particular problem is to multiply by r. If you multiply by r, then we're going to get this, and we can convert it to a y, and then convert r squared into x squared plus y squared. We're going to bring the negative 4y over, complete the square, and you can see we get a circle. Okay, we're going to do much the same thing with this particular problem. We're going to say r equals 2a cosine theta, and we're going to multiply both sides by r. I'm going to multiply this by r, and I'm going to multiply by r here. And then I'm going to get r squared is equal to 2a r cosine theta. I'm going to make my conversions here and here, and I will have x squared plus y squared is equal to 2a, and that's an x. Now a is a constant, so this is all in rectangular coordinates, and you could put it in the circle form much like we did the problem before that. Okay, now I'd like to talk about actually graphing without using the calculator. So what we're going to do is it says to graph from negative pi to pi. We'll graph from 0 to pi. Take a look at it. I'm going to substitute the theta value. So this will be 0 minus 1, and that answer will be 2 take away 1, which is 1. So this answer is 1. 2 cosine of pi 6 minus 1 is equal to 2, and then this will be root 3 over 2 minus 1, which is going to be about 1.7 take away 1, which is about 0.7. This is about 0.7. 2 cosine, and now the next one is pi thirds minus 1, which is equal to 2 times 1/2 minus 1, which is going to be 0. So I'm just going to fill this out, but you saw how I go about doing it. Okay, and I'm going to go ahead and graph it. 0, 1, and pi 6, and then it's going to be 0.7, and pi thirds, 0, and pi halves, it's not going to be 1 but negative 1, so I go this opposite direction. And then 2 pi thirds, and then I have to go opposite, which is 2 right here. So far the graph looks something like this. And then 5 pi 6 right here, I have to go negative 1, 2, 0.7, and then pi negative 3, 1, 2, 3. So it's going to look something like that. Now, to go ahead and take a look at these, I want to have negative angles. I'm going to put this here. When I put a negative angle in here, I want you to notice that when I put a negative angle in for cosine, I'm just going to get these same values. So I'm going to go ahead and graph negative pi 6, so that's down here, and then I'm going to graph 0.7, so that's right here, and then negative pi thirds, which is right over here, and then it's going to be 0. So this is kind of going like this. And then at negative pi halves, it's going to be negative 1, which is right here. And at negative 2 pi thirds, which is right here, is going to be negative 2, 1, 2. And at negative pi 6, and then it's going to be 1, 2, 2.7. And then at negative pi right here, then it's going to be negative 3. All right, so, and that's that Limacon that we had seen before. Now, to wind up the screencast, I want you to see a small polar gallery. And these are all the kinds of curves we can get in the format that we have for them. And those are the Limacon curves, lemniscate, and spiral.